To follow up the factoring video I just did, we're going to do one that has a GCF on here. It's right below that, same page, number 5. This is what we learned on the most recent lesson in class, but I will work through an example with you. You see number 5 and 4, very challenging with fractions. I'm not going to do those. As a matter of fact, we'll just make those bonus. You're not going to have fractions on your test, so you don't have to do those unless you want to challenge yourself, okay? Which these 4 here will be good enough, okay? I'm just going to do number 2. That seems reasonable. So in class the other day, we talked about how to do this. The first thing you want to do is you want to look at all 3 of the expressions that we have here. And starting with the numbers, we're going to have to try to find a GCF for the numbers. What is the greatest common factor of the numbers? Well, most of you might think 3 is, because 3 goes into all of these, but it's not the greatest one. Actually, 9 will go into all of these, so I know a 9 will have to be part of that. After you decide on your number, then you want to look at the variables. So look at all the x's, and you have to ask, how many x's can I divide from all of these? Well, is 4 the number of x's? So is it x to the 4th? Okay, well, it's not. All right, so the problem is this: I can't divide 4 x's from x to the 3rd or x squared. So that won't work. Okay, I'm going to have to come up with another option. Well, what amount of x's can I use? Well, I can only take whatever the lowest power is. I can only take at most from each term 2. So I'm going to put that, x squared. And this is our GCF. Okay? Now, that's not the actual answer, because you have to write the answer to these problems as a product of this GCF. So we're going to rewrite this, 9x squared. And the product means we got to multiply it by this after I divide out this GCF. So I'm going to go to each question here, and I'm going to divide away 9x squared. So we start with the numbers. Negative 9 divided by 9. Well, that gives me a negative 1. Okay, and you don't have to draw this one, but I will just to help out. Okay, then you look at the x to the 4th. All right, x to the 4th divided by x squared. Well, when you do division with exponents, you subtract the numbers. Okay, so this is essentially you take the power of 4 and subtract the power of 2 from it. So that is x to the 2nd. And we're done with that first term. Now we go to the next one. All right, same idea. Start with the number 9. This 9 divided into 45. Well, that's 5. Okay, I'm going to have to erase this right here. Oh my gosh. Okay, well, hold on. Let me fix this. Oops. Okay, let me put parentheses, 9x squared. Sorry. Okay, 9x squared. So that 5 is so 45 divided by 9 is 5. Then x to the 3rd divided by x to the 2nd. Same principle where you subtract the exponent. So it's 3 minus 1. So it's x to the 1st. I'll put the 1 there. You don't have to put the 1. You don't have to. But you can if you want. It's not wrong. Next, 9 divided into 9 to 9 here. This is sort of the same as what we just saw. So it's minus 1. Okay, that 9 divided by 9 becomes a 1. And then x squared divided by x squared, when you subtract those, it becomes x to the 0. Okay? But you don't necessarily need to write it like this when you subtract it, because anything to the 0 power is just 1. And in class, we said these cancel out. I don't like calling it cancel out, but they divide each other away. So let me get rid of this 0 here. And we just want an x right there. Okay, and this is the answer to this question. There's nothing more that we can do as far as factoring goes on that. Actually, I made a mistake. Hold on. We need to actually get rid of the x as a whole. So let's get rid of that. So this is going to be minus 1. Sorry about that. So there should be no x because it divides away. There we are. That is our answer right there. We cannot factor that any further. We're completely done.